Hi, today we are going to solve the problems sum number 3 and 4 from exercise 2.2. In my previous video, I have given the explanation about zeros of polynomial and we have solved the problems sum number 1 and 2. I have given the video link in the description. You can check it. And now we can move on to sum number 3. That is, verify whether the following are zeros of the polynomial indicated against them. The first subdivision is p of x equals to 3x plus 1, x is equal to minus 1 by 3. So they have given p of x equal to 3x plus 1. Now we have to substitute x is equal to minus 1 by 3 in the place of x in p of x, and we have to show that the p of x will be equal to 0. We'll do that. Substitute x is equal to minus 1 by 3. So p of minus 1 by 3 is equals to 3 into minus 1 divided by 3 plus 1. So 3 and 3 will get cancel out. We will be having minus 1 plus 1, which is equal to 0. So if p of x equals to 0, then the x value is a 0 of polynomial. Therefore, minus 1 by 3 is a 0 of p of x. The next problem is p of x equals to 5x minus pi. X is equal to 4 by 5. So, p of x is 5x minus pi. So, we have to substitute the given x equal to 4 by 5 in the place of x in p of x. We'll do the substitution. P of 4 by 5 equals to 5 into 4 by 5 minus pi. 5 and 5 will be getting cancelled out. So we'll have 4 minus pi. If the answer is equal to 0, we can say that it is the 0 of polynomial p of x. But here we are getting the answer as 4 minus pi. So x equals to 4 by 5 is not a 0 of polynomial x. Next problem, subdivision 3, p of x equals to x squared minus 1, x is equal to 1 and minus 1. So they have given two values for x, 1 and minus 1. We have to solve it for both the numbers. So p of x is equal to x squared minus 1. First we'll substitute x is equal to 1. So p of 1 equals to 1 squared minus 1. 1 squared is 1 minus 1, which is equal to 0. Therefore, x equals to 1 is a 0 of polynomial. Now we'll substitute x is equal to minus 1. P of minus 1 equals to minus 1 squared minus 1. Minus 1 into minus 1 is 1. Negative number into negative number gives a positive value, which is equal to 1 minus 1, which is equal to 0. Therefore, 1 and minus 1 are zeros of p of x. Fourth subdivision is p of x equals to x plus 1 into x minus 2. X values are minus 1 and 2. So p of x equals to x plus 1 into x minus 2. Substitute x is equal to 1. P of minus 1 equals to minus 1 plus 1 minus 1 minus 2. So in the places of x, we are substituting minus 1. So minus 1 plus 1 is 0. Minus 1 minus 2 is minus 3. So 0 into minus 3 is 0. Now substitute x is equal to 2. P of 2 equals to minus 2 plus 2 plus 1. 2 minus 2. 2 plus 1 is 3 and 2 minus 2 is 0. 3 into 0 is 0. So we are getting the answer as 0. Therefore, x is equal to 2 is also a 0 of polynomial. Therefore, x is equal to minus 1 and 2 are zeros of p of x. Now we'll move on to the fifth problem. P of x equals to x squared. X equals to 0. So we have to substitute x is equal to 0 in p of x. So P of 0 equals to 0 squared, which is equal to 0. Therefore, 0 is a 0 of P of x. Sixth problem is P of x equals to Lx plus m. X is equal to minus m divided by L. So, the given P of x is Lx plus m. We are substituting x is equal to minus m divided by L. So, we are getting P of minus m divided by L equals to L into minus m divided by L plus m. So, L and L will be getting cancelled out. So, balance we have minus m plus m, which is equal to 0. Therefore, minus m divided by L is the 0 of P of x. Now, we'll move on to the seventh subdivision, that is P of x is equal to 3x squared minus 1. X is equal to minus 1 divided by root 3 and 2 divided by root 3. They have given the denominators as root 3s here. So the given P of x is 3x squared minus 1. We are going to substitute the first value, x is equal to minus 1 divided by root 3. So P of minus 1 divided by root 3 equals to 3 into minus 1 divided by root 3, the whole squared minus 1. So minus 1 divided by root 3 into minus 1 divided by root 3. Squaring. So we are multiplying this. So minus 1 into minus 1 is 1. Root 3 into root 3 is 3. We will substitute 1 by 3 in the place of minus 1 by root 3 the whole squared. So we get 3 into 1 by 3 minus 1. 3 and 3 will be getting cancelled out and we get 1 minus 1, which is equal to 0. Substitute x is equal to 2 divided by root 3. So P of 2 by root 3 equals to 3 into 2 by root 3 the whole squared minus 1. So 2 by root 3 into 2 by root 3 is 4 by 3. We'll substitute 4 by 3 in the place of 2 by root 3 the whole squared. 3 and 3 will be getting cancelled out and we have 4 minus 1, which is equal to 3, that is not equal to 0. Therefore, minus 1 by root 3 is a 0 of P of x, but 2 by root 3 is not a 0 of P of x. And the eighth subdivision is P of x equals to 2x plus 1. X is equal to 1 by 2. Now substitute x is equal to 1 by 2 in the place of x. P of 1 by 2 equals to 2 into 1 by 2 plus 1. 2 and 2 will be getting cancelled out. We get 1 plus 1, which is equal to 2, which is not equal to 0. Therefore, 1 by 2 is not a 0 of P of x. And the next problem is fourth problem. Find the 0 of the polynomial. First problem is P of x equal to x plus 5. We can find the 0 of the polynomial either by equating P of x equals to 0, that is x plus 5 equal to 0, or in the previous video we have found out a formula for the general linear polynomial. You can use the formula too. I have solved out in both the methods. Now we'll equate this to 0. X plus 5 equals to 0. Transposing 5 to the other side, we get x is equal to minus 5. Therefore, minus 5 is the 0 of polynomial. We'll check this with the general formula. X is equal to minus of constant term divided by coefficient of x. Here the coefficient of x is 1 and the constant term is 5. So we get minus 5 by 1, which is equal to 5. And the next problem is P of x is equal to x minus 5, equating x minus 5 to 0. So transposing minus 5 to the other side, we get x is equal to 5. Now we'll check this with the general formula. In this polynomial, coefficient of x is 1 and constant term is minus 5. So we get minus of minus 5 divided by 1, which is equal to 5. And the next problem is P of x is equal to 2x plus 5, equating P of x equal to 0. 2x plus 5 equal to 0. Transposing 5 to the other side, we get 2x equals to minus 5. Transposing 2 to the other side, we get x is equal to minus 5 by 2. So minus 5 by 2 is the 0 of the polynomial. Using the general formula, we'll check this. Here the coefficient of x is 2 and the constant term is 5. So we get minus 5 by 2. Fourth problem is p of x equal to 3x minus 2. Equate this to 0. 3x minus 2 equal to 0. Transposing 2 to the other side, we get 3x is equal to 2. Minus 2 when transposing gives you plus 2. Transposing 3 to the other side, x is equal to 2 by 3. Therefore, 2 by 3 is the 0 of the polynomial. In this polynomial, coefficient of x is 3 and the constant term is minus 2. So using the formula, we get minus of minus 2 divided by 3. Minus into minus will be plus. So 2 by 3 is the answer. Now the fifth subdivision is p of x equals to 3x. Equate 3x equals to 0. Transposing 3 to the other side, we get x is equal to 0 by 3, which is equal to 0. Therefore, 0 is the 0 of the polynomial. Using the general formula, here the coefficient of x is 3 and the constant term is 0. While equating, we get 0 by 3, which is equal to 0. Sixth subdivision is p of x equals to ax, where a is not equal to 0. Equate a of x equals to 0. Transposing a to the other side, we get x is equal to 0 by a. Therefore, x is equal to 0. Therefore, 0 is the 0 of the polynomial. Using the general formula, we'll check this. In this polynomial, coefficient of x is a and the constant term, there is no constant term. So, the constant term is 0. So, if we equate, we get x is equal to 0 by a, which is equal to 0. And the seventh problem is p of x equal to cx plus d, where c is not equal to 0. C and d are real numbers. So, equate p of x, that is cx plus d equal to 0. Transposing d to the other side, we get cx equals to minus d. Transposing c to the other side, we get x is equal to minus d by c. Therefore, minus d by c is the 0 of the polynomial. Using the general formula, in this polynomial, the constant term is d and the coefficient of x is c. So, we equate, we get minus d by c as the answer. So, find the 0 of the polynomial, you can either equate the p of x equals to 0 and find the value of the x, or else you can use the general formula of ax plus b, that is x is equal to minus of constant term by coefficient of x to find the x value. In the next video, we'll see about the remainder theorem. If you have any doubts regarding the subject, post your queries in the comment section. Like and subscribe and click the bell icon to get the new videos updates.